Okay, gang, we were taking a look at section, I think it was 2.1, where we found the slope of a secant line and the slope of a tangent line. I wanted to show that to you again. I have a couple of figures here. I think I'll use this one right here. If you take a look at this figure, notice how we have the slope of the secant line in green, and then we got the tangent line in red, right? And we said that we wanted to determine the slope or the rate of change of the black curve, that's the function y equals f of x, that's shown right here, at that specific point. But the reason that we couldn't actually find the slope of it is because we couldn't find we didn't have 2 points, okay? And the workaround for that was, okay, start with a second point. That's what point Q is right here, okay? Now notice, kids, for point P, there's a specific value of x chosen for us. In this case, x is equal to the number a. Point Q is a little bit further away. Notice horizontally it's h units away. You can see that a little bit better down here. Now notice that the slope of that green line is going to be considerably less than the slope of the tangent line. The idea is to approximate the one with the other. Okay, now the approximation of the slope of the secant line to the slope of the tangent line in the current view is pretty lousy, okay? However, if we allow the value of h to get smaller, let me make the picture just a little bit smaller here. See, the value of h right now is about 4.5. So I'm gonna shrink that a little bit, and note, gang, look at the figure. As I shrink the value for h, notice that the point Q is getting closer and closer to the point P. Okay, so we say that the value of h is approaching 0, right? The value of h is approaching 0. As we do that, the point Q slides towards the point P. Watch this. Notice how the tangent line and the secant line are becoming much more aligned with each other. So theoretically, boom, the one is right on top of the other. This is the reason why we define the slope of the tangent. In fact, it's right here, right? We remember this expression, f of x plus h minus f of x over h, as the difference quotient from pre-calculus. But we also know that that's the slope of the secant line, which we can see written right below it. The slope of the tangent line, we said, was defined as the limit of the difference quotient as h approaches 0. I think it's a little bit easier to see when you've got like a bit of an animation, if you will, okay? If you would like, we can move the point P also. Maybe we want to find, maybe we want to find the slope or the rate of change of the function at this particular point on the curve, okay? So we choose another point Q, which we see right here, draw the secant line, and allow the value of h to get smaller and smaller until the slope of the secant line is going to approach the slope of the tangent line. Theoretically, we say that the secant line lands on top of the tangent line. Okay, so this was the whole thing that we were talking about in the presentation for section 2.1. Now, I'll just mention it to you here because I think it's worth mentioning now when we get into section 3.1 and actually all of chapter 3 thereafter. It's kind of cool to see that, isn't it? Moving the points around. This expression, kids, the limit of the difference quotient as h approaches 0 is the slope of a tangent line, but it is so important that actually it gets its own name and it gets its own symbol. Actually, it gets several symbols. I'll mention this again in a pencast where I can actually write on the screen itself. But the limit of the difference quotient as h approaches 0 is defined, is defined as the derivative of the function f of x. Okay, we call that limit of the difference quotient as h approaches 0 the slope of a tangent line. That's true. But it's also called the derivative of the function at the point where x is equal to a. In other words, that blue dot, look in the figure, see the point P? The slope of that tangent line right there, that red tangent line, is defined as the limit of the difference quotient, but that limit is called the derivative of the function at the point P. In other words, at the point where x is equal to a.